So here is another question on properties of electromagnetic waves. So it is given that the electric field of a plane electromagnetic wave in vacuum is represented by Ex is equal to 0, Ey is equal to 0.5 cos 2 pi into 10 to the power 8 t minus x by c, and Ez is equal to 0. So it is given what is the direction of propagation of the electromagnetic wave, determine the wavelength of the wave, and compute the component of the associated magnetic field. Okay, so here one thing which you have to understand is the basic representation of electric and magnetic field. So let us take the electric field first. The electric field we can express as, let's say, ET, the basic representation, the very basic representation is E0 cos omega t minus kx, where E0 is the amplitude, omega is the angular frequency, t is the instantaneous time, k is the wave number, and x is the propagation direction. I'm assuming that it is the propagation direction is along x. We have already discussed it in the basic concepts of electromagnetic waves. So now we can rewrite it as E0 cos 2 pi f into t, where omega is equal to 2 pi f. Omega is the angular frequency in radians per second, f is the frequency in second inverse or hertz. Wave number k is written as 2 pi by lambda, where lambda is the wavelength, and again x, the propagation direction. Okay, then we can again write it as E0 cos 2 pi ft minus 2 pi by lambda. We can write it as what? Speed of the wave, that is c, 3 into 10 to the power 8 meter per second, and the time period. Lambda is product of speed of electromagnetic wave and the time period of the wave, c into capital T into x. Okay, now again we can write it as E0 cos, if we take 2 pi f common, 2 pi f we take common, and then we have t minus x by c, 2 pi f into x by c. Okay, this. Okay, here you can make another substitution, another change, that is here 1 by t is equal to f. So here you can make another change, how we got it here, that is E0 is equal to cos 2 pi ft minus 2 pi f x by c. Okay, because 1 by t reciprocal of time period is equal to frequency. So this 1 by t, that became again 2 pi fxc, we got 2 pi f common we took, and that is equal to t minus x by c. So this is the representation of electromagnetic wave. So if we compare this equation with the given equation, which is Ey is equal to 0.5 cos 2 pi into 10 to the power 8 t minus x by c. If we compare it with that, then we'll see that here the amplitude E0 of the electromagnetic wave, that is equal to 0.5. The frequency f is equal to 10 to the power 8 hertz, and it is propagating along the x direction. So to answer the first question, that is the direction of propagation of the electromagnetic wave, it is along x axis. Okay, that. Then we have to determine the wavelength of the wave. Okay, here it has been mentioned that the component of the electromagnetic wave, the amplitude variations along the x axis is 0, along the z axis is 0. So obviously it is moving along the x axis, and the amplitude variations are along the y axis. The amplitude variations are along the y axis. It is propagating along x axis, amplitude variations of the electric field are along y axis. Then we have to determine the wavelength of the wave. So frequency is equal to 10 to the power 8 hertz. We know lambda wavelength is equal to ct. We have already know it is the product of speed and time period, which is equal to, we can write it as c by f, because time period is the reciprocal of frequency. That implies lambda is equal to c by f, which is equal to 3 into 10 to the power 8 by frequency, which is equal to 10 to the power 8. This gets cancelled. So lambda is equal to how much? Lambda is equal to 3 meters. So the wavelength lambda of the wave, that is equal to 3 meters. Then it has been asked to find the component of the associated magnetic field, that is the amplitude of the magnetic field. So we have already got the amplitude of the electric field E0 is equal to 0.5. Okay, obviously it will be in terms of volt per meter. So using the relationship E0 by B0, that is equal to C, where E0 is the amplitude of electric field, B0 is the amplitude of magnetic field. That implies B0, amplitude of the magnetic field, will be equal to E0 by C, that is equal to 0.5 by 3 into 10 to the power 8. That will be equal to it is coming around 1.66 into 10 to the power 9 Tesla. Now here, if you see, if we try to depict this whole situation graphically in terms of diagram, it is something like this. So we have, first let us draw the axis. We have the x-axis, we have the y-axis, we have the z-axis. So first let us represent the electric field. So the electric field, the amplitude variations are along the y-axis. How do we know that? Because it is represented very clearly in the question. EY means electric field along the amplitude variations are along the y-axis. So it will be along the y-axis. The amplitude variations will be along the y-axis, like this. Okay, like this. Then the electromagnetic wave is moving along x-axis, positive x-axis. So obviously the amplitude variations of the electric field is along the y-axis. So the electric wave component is confined to xy plane. So obviously the magnetic field, it will be in the mutually perpendicular plane, which will be along the xz plane. So the electric field is in xy plane. Okay, the electric vector. So obviously the magnetic vector wave, it will be in xz plane. Okay, and the amplitude variations of the magnetic field, it will be along the z axis. Okay, it will be along the z axis and it will be like this. As they have the same frequency, they have the same phase, so they will attain maxima and minima at the same time instants. So Bz will be represented as B0 cos 2 pi into 10 to the power 8 to t minus x by c, where this B0 is equal to 1.66 into 10 to the power minus 9 Tesla. So it will be like this: Bz is equal to 1.66 into 10 to the power minus 9 cos 2 pi into 10 to the power 8 into t minus x by c. This is the thing. Okay, so this is the whole solution here. Okay.